the so I've just started it up, and we've got the new coil running, and I did do some tests on there. I actually loaded the output, and I connected the LEDs because the output of that coil is actually, like I predicted, it's less than what the other, well, these coils together in series is less than what we're getting on this side. It's, well, it's much. Originally I connected them directly because it was about 4 volts. The LEDs were a little bit overdriven. They were taking 70 milliamps. So what I've done is put this 150 ohm resistor with this wire wound resistor here in series, so that we don't overdrive the LEDs. And with that 100 resistor, we're actually drawing about 10 milliamps when it's up to speed. I'll put the oscilloscope on. Just give me a sec. And I've also been having some thoughts about how to improve or get rid of this drag problem altogether. Some ideas I've been having about a new design, making it bipolar, and that's very difficult to do. But I'm trying to economize a bit, so I want to try and use the existing platform that it's sitting on, if possible. But by omitting the middle rotor, by taking out the middle rotor section. So at the moment we're on 3 rotors, we're on 1, 2, 3 behind the canopy. If I take out the middle rotor, I can use the middle section as an anchor point to hold stationary coils. The idea is that the coil would be suspended by the middle section on some arms that go in, and the coil would be basically between a rotor section on the inside with the passing the coil. Then it would then on the out. Now this is the tricky part. Doing that is extremely physically difficult because of the way it's arranged. So I'd have to omit the middle rotor because the coil would have to be suspended between the two inner and outer magnet arrays as it's passing. So you don't see that in nature, I suppose. That's what I was saying. I suppose what I could show you is this old rotor here, right? Now imagine that we have this rotor, which would be the inner rotor section, and our coil would be vertically wound, and then there would be a back plate that comes out, and then we have another section of magnets. Actually, it's very similar in a way to that magnet motor thing I was working on. Hang on, let me just go and grab it. I don't want to make you dizzy, so hang on. Let's see. Right, so if I get my old magnet thingamajig, it'll probably be easy to explain it. Right, so sorry if I'm making you dizzy. Right, so I put this thing I was experimenting with, obviously it didn't work. If I take this out, you can see that on here we have the outside magnets on here, right? And we have the inside magnet arrays on here, right? Well, obviously I can't use this because the spacing is too close, right? This was something I was experimenting at last year, was it, a few months ago. Now imagine that we have a coil suspended in between the two magnets, and imagine that the magnets that we've got magnets facing in, which we don't with this, right? Imagine we have magnets facing in with south, and then on the other side we have magnets facing in with north, and the coil passes between them. Well, this is the sort of thing. So but obviously I'm not using this. This is the thing. about road. I've been working out in my head how to make this possible, and the only way I could come up with would be to suspend the coil, anchor it to the pillars, the struts that hold it all together, and have an outside rotor, a rotor on this side and a rotor on this side, and it would basically be anchored from the middle. So I wanted to try and make this so that it would be on the same stand, but in practicality it would get too big, so I am thinking about remodeling it and making something smaller because it would get too big. I don't want the thing getting out of size, it would just get ridiculously big, you know what I mean? So I'm going to model something in SketchUp, and I'm just going to see how I can do it with the existing magnets I have, because I don't want to be buying more magnets, different sizes and all that shit, because it cost me a fortune. And if possible, I want to use my existing segments for the inside, but instead of probably using 6 of these, I'll probably use 3 or something, so we'll be on a tighter circumference. So maybe I could use 3 on the inside and 3 on the outside, so that I can make the thing smaller. I was thinking about that, but I haven't decided yet, because it really doesn't, it's not going to come into, it's not going to make sense to me until I can model it, start to model it and see how it looks and everything. But anyway, the coil that I made, this new coil, it does work pretty well. If I short out these LEDs, bypass this resistor here, it gets really bright. I don't know if I can show you that. Let's see if I short them out a minute. See how bright that gets. When I'm shorting them out, they're drawing about 70 milliamps. I can't seem to do it now. Hang on a minute. It lit up briefly then. Hang on, I'll use my scissors. Right. See, that one goes dim. This one's just barely lit because it's not getting enough voltage. So if I can just see, that draws 70 milliamps when I do that. You see how bright they get. Right, I can't keep, it keeps moving. I'm trying to do it with one hand. So with that on anyway, we get up to about 1200 RPM once I leave it alone for a while. When these LEDs are drawing about 10 milliamps, it gets up to about 1200 RPM. I'll show you the waveform. It's quite a clean waveform. The yellow channel is the new coil. Right, the yellow channel is the new coil. It looks like the same waveform, but it's not, because they're on a different range. The blue coil is on the 3 volt per centimetre. The yellow coil is on the 2 volt per centimetre range, so basically they look the same, but the yellow waveform is a cleaner waveform. It's got less noise on it, less stepping, but the noise on the blue waveform is caused by my triacs, which are on this board down here. So these triacs are creating that noise on the waveform, but there was a stepping issue on there before anyway, which was about there. Where's my finger? It was about there, but we don't see on the much smooth. I can wait. That's just. I'm using the wrong. Hang on, I'm wrong one. I want this one. Move the blue one down a bit. You can see the yellow waveform. It's pretty clean. Pretty clean sine wave. So yeah, I'll move that back up again. My pots are getting dusty, I think. So anyway, those are the outputs. You can see the blue channel. We can see that we get about 25 volts peak to peak on the blue coil, which is closer to the rotor anyway, and we're only 14 volts peak to peak at the moment on the yellow channel, which is the new coil, and cyclic RMS is 4.4 volts on yellow channel. So yeah, I just wanted to show you. So I did predict it would be lower output. That's because of the rotation on the foil, these foil tubes which I've got below the coil. So it does seem to have a lot less drag, which is a good thing. So anyway, I am going to be modelling something up in SketchUp. I want to see if it's practical, and I've got to make sure it's sturdy and that we're not going to get a lot of flexing issues with the coil. So I want to make the thing a bit smaller. I want to make it smaller so that we don't run into distortion and warpage and all that kind of stuff that seems to keep haunting me. So anyway, so I'm going to do that soon. I'm still working it out in my head before I actually model anything, because once you start modeling it, it's difficult to undo what you've done. And yeah, I just want to work it out in my head as best I can, really. Because the idea is that because we have dual pole, because we have my finger, say this is in South Pole and this is North Pole at the bottom, imagine that these are moving across the coil as it tapers out. As it tapers out with the coil, so if the coil is in between my fingers, right, as it moves out, then the lens effect would be cancelled out, because as it comes to the end of the coil, it would taper out, and the cancellation, the drag, the lens effect would be virtually non-existent, because it's using a similar method to my concentrics. So my concentric magnet arrays, they worked in such a way that we saw virtually no drag on them, but we didn't get much output with these. But obviously, because the coil itself is moving between two fields, north and south, we should have a much better output. We should gain, we should have a lot higher voltage and higher current output, because it's between two poles. It's actually sandwiched between the two poles, so we get a better coupling there. So in theory, I should be able to do away with one of the rotors anyway. So anyway, it's just something I'm working out right now. I've got to come up with something that's stable, and obviously if I use my coupling rods with these things with the foil wrapped around them between the rotors that are moving, or actually probably won't be directly, because it can't go all the way through the coil, because it would get hooked up on it. So I would have something like this where they were separated and there was a gap between where it enters the coil and exits the coil. I should be able to make something much more efficient. Anyway, as I said, give me a catch. A quick update on this. So anyway, that's it for now, I think. I've shown you the waveform, and we do seem to get a good output on that second. So this is why I don't see as much drag on this as what I do on the other side. When I short that one out, it drops a bit, but not as, it drops faster, I think, than it does on this side. But then this voltage is lower anyway, so we might get more current on this side than the other side. Yeah, I'm just trying to find the best design, because as I said right from the outset when I started on this project, this is experimental. It's a jig for testing out various ideas, and I am happy with the way this other new coil design works. But I was thinking about how else I can improve, reduce the lens effect on it, and I think the only way to do that is to go bipolar. That's two magnetic poles of opposite field, and one on the outside, one on the inside, and as the magnet arrays, the two poles are leaving the coil, the two poles would basically join together, so it would automatically switch as it leaves, if you get what I'm saying. It's hard to explain it, I know. So it is a bit of a challenge to model this physically. It's a physical challenge more than it is a design challenge. Problem, you know, it's coil it basically there and the two poles, and having the ability for the outside part to be rotating on this side and the other side to be rotating, and anchor the coil in the middle between the two rotors is the problem, because there's no way to hold the coil, suspend it basically in mid-air between the two sections of the rotor. The only way to do that in theory is to have a split rotor, which is what I'm looking at, a split rotor system, and the part that holds the coil would have to be placed between the rotors, and the rotor would have to be slid on over the coil, and I can see problems that I might encounter with that, so I'm going to have to leave myself lots of space, give myself plenty of room so that there's less chance of it catching or rubbing on anything. So this is why I'm thinking about doing it smaller, making something smaller, so I have more, I don't print so much plastic out, and if it becomes no good I can expand on it and make things a bit bigger on the outside, so that the coil itself isn't going to be rubbing on anything and catching on anything, and it's going to be a bit of a challenge, I know, but I think we can do it. I think I can do it. I just need enough space in the middle section, probably about 1.5 inches between the to give it the strut strength, so it doesn't wobble about and stuff like that, you know, so we don't have things wobbling and bouncing around. It would, last thing I need is to be holding the coil in the middle with a single tiny point, because it would wobble about, and so we need a fair range, a fair large area really to hold that coil stationary, if you get what I'm saying. Anyway, I'll keep you posted when I get something drawn up and let you know later on. So anyway, that's it for now. Bye for now.